Hello, everyone, and welcome to this fifth webinar of the Axiom Programming School. Today, we are going to be talking about the topic of how to model the data of our programs. And we will be discussing what is data modeling to begin with. But before we go, before we proceed with the topic of domain modeling, let us briefly recap what we have learned during the past 4 webinars. So let me just share my screen, as always. Okay, so I'm now sharing my screen. Please write in chat if you can see my screen, and if you can hear me well. Okay, great. It seems it works. So here is the gist, the context of what we were discussing during the previous seminars. So first, and the most important, arguably, concept on which everything else builds upon is data and logic. So all the software that is out there, it can be represented as, it can be seen as data and as logic. And we are going to be seeing how the programming language that we are using, Scala, is good at expressing both of those concepts. And the data is something like text. It can be a text, it can be a number, it can be a picture. And the logic is operations over this data. So for instance, you can send that text to Facebook, for example. That is supposed to be Facebook's logo. And you can upload the picture to your favorite social network, and so on and so forth. So that's data and logic. Next, what we have seen is that the language that we are going to be using in this course is Scala, and we have seen how to write Scala. We have covered the software called Scastie. So you can find it from the page of the book. You can click Write Code, and that's a little online code editor where you can write the program and in Scala, and it will be executed. Then we have proceeded at looking at some practical applications of Scala, and we have seen that it can be very nicely used as a calculator, as a glorified calculator. So it can do things like 2 + 3. And after we have seen that, we have proceeded into looking at how we can use that calculator in practical life. So we have seen how to calculate the vacation costs. So if you live in one city, and if you're planning to go for a vacation to another city, you can use Scala to perform this calculation, as is shown here, for example, at this code snippet that I'm highlighting. We are living in Helsinki, and we are planning our vacation in Barcelona. And the vacation costs consist of the flight cost, of the hotel cost, of the meals costs, and of the desired duration of stay. And then we can use Scala to perform the mathematical operation to calculate how much the entire vacation will cost us. So if we put it in Scastie, it's going to compute to perform the calculation and tell us how much it will be. And during the previous seminar, we have started to see a little bit of what programming is actually all about, because programming is the art of abstraction. So what is abstraction? So during the previous seminar, we have seen the first case of the usage of abstraction in a programming language. So consider, for example, that you have not a single city, but 2 cities where you're going to for a vacation. So you're going first from Helsinki to Barcelona, and then from Barcelona to Rome. And then you want to calculate the cost of going to both of those cities and the total cost of your vacation in its entirety. So if you look at this snippet, we see that we are performing essentially the same thing for both Barcelona and Rome. So the code that calculates vacation cost for Barcelona is similar to the code that calculates the vacation cost of Rome. And what we humans are notoriously good at is figuring out how to automate our work. And this is what computers are all about. So that's where the concept of a method comes in. So a method is a formula that a method is a formulaic expression of a certain computation. So let us have a recap of how it works. So a method and any abstraction to begin with is appears whenever we have several similar cases where we do similar work. So in our case, it is Barcelona and it is Rome. And we need to do similar work for both of those cities. And the work in question is we need to calculate vacation cost for both of those cities. And for both of those cities, the vacation cost is composed of the flights cost, plus daily expenses. So we have the duration of stay, times, and the daily expenses themselves are composed of meals and hotel. So this formula over here, it is supposed to be applied both to Barcelona and both to Rome. And methods are exactly that. They allow us to capture a formula without specifying the concrete cases of application of this formula. And then they provide us a mechanism to apply those things to apply this formula to those cases. A more concrete example, a more concrete intuition of what this actually is consider, for example, in real life, we all like juice, fruit juice, and juice is made out of certain fruits. It can be made out of apple, can be made out of strawberry, can be made out of pear, and of melon, for example. And all of those fruits, they can be turned into juice. And so the work that needs to be done for all of those fruits is similar. And so we humans, we made a machine to automate this work. So there is a juice making machine. That all those fruits can go into, and it will produce juice. And you can put any fruit in there, any case, and this machine will turn those fruits into juice. And so the same thing is about methods. We have different cases of cities where we can go for vacation. So and so on and so forth. And we need to do similar work for every of those cities. And so we create a machine using our computers, which is a calculator. And this machine can do this work for us that we were doing manually to calculate the cost of vacation for all of those cities. So in both of those cases, it is exactly the same case as a case of generalizing work from case-to-case basis to a general concept, to a general formula that can be applied to all of those cases. So cases in our case are either fruits or cities, and the machine that automates the work that needs to be done is either the calculator or the juice-making machine. And the result is, well, the result of the work. So it is either juice or the cost of the vacation. So is that clear? I decided to take a little bit more time on methods to just remind you of this concept, because it is in the essence of all the programming. So feel free to write in chat if anything isn't clear. And just to remind you how we use that in practice is as follows. So we have the method defined using the def keyword, and the name of the method, the stuff that is changing from case to case. So in our case, our cases are cities, so the cost of the flights, the hotel cost will be different, and so on. And that's how we define methods. That's called the operation of abstraction, where we generalize the work from individual cases to a formula. And then every method can be applied to the cases it is defined on. So the application is done as follows. So calculate vacation costs, and in the brackets we write the parameters that are specific to that particular case. And if you run it, it is going to print us the output for the vacation. So that was the stuff that we covered during the previous seminars. And during this seminar, we are going to take this a little bit further to see how you can build more complicated stuff with Scala, because so far we have just seen how to use it as a calculator. And now we are going to see what else you can do with it. Well, we are going to be looking at how to build a flights search engine, how, at least in the very basics of it, at least at the very essence of it. So what is a flight search engine? It is a website like Skyscanner, for example, where you can search for flights. So you enter the city you're living from, you enter in the destination and the date of the departure, and then it shows you the available flights to that location. So this process is going to be done in several parts, because as we have seen before, everything in programming is composed of data and logic. So there is some data that goes into the process, and there is some logic that goes into the process. And we are going to start by looking at the data component of the process of this application. Why? Because usually the way we model our problem using data, it defines the logic that we can do on that problem, that you can express the problem with. So let's have a look at what happens, what kind of data we need to model. So in case of a flight search engine, we have a form where you see, say, the departure place, the destination place, the date, and then there is a button to search the flights. And when you click this button, what happens is your browser sends requests to the server, which has a database. And a database is where the big servers store information. So this is the database of flights. It contains all of the flights that this website knows about. So in case of a big search engine of flights, it contains all of the flights in the world. And what happens next is there is some logic that performs a lookup in these flights. So logic performs a lookup in this database of flights. It finds some flights that match our criteria, and they're returned to the user in a nice list. Scala in general, it is very good at modeling all of this part. So not the forms, not the front end in technical terms, not what the user actually sees, but the application that runs on the server in the company. and performs the logic and stores all the flights. Scala is the best in this domain. It can also do the front end. It can also define the forms that the user can see. So the search form, the results form, but it shines at the backend. So the stuff that is executed on the server, that runs on the server, is called the backend. And during this seminar, we are going to be concerned with only this part. So the data. We are not going to be touching the logic part during this seminar. We're only going to be touching the data part. And before we go to the data part, we need to figure out what exactly the objective is here about the data part. Well, what is the data part of a flight search engine? Well, it is a collection of all of the flights that the system knows about and is ready to present to the user. So we need a way to represent the flights in Scala so that Scala can store them and operate on them. That's like the foundation that you do before you solve any problem in programming. You think about how am I going to represent the things that I'm operating with to the computer. And when I say data modeling, it is about what kind of data types I'm going to be using for this particular problem. Now, at the very first seminar, we were discussing that in programming, all of the data types, they are made out of other data types. And there is one most fundamental data type. So can anyone write me in the chat what is that fundamental data type out of which all the other data types are made of? Yes, we have integer, we have numbers, so that's exactly right. So the fundamental data type is a number. And then the follow-up question, do you remember how other data types are made out of, other data types? How are they made out of other data types? So string and double are not fundamental data types of programming. They are fundamental data types of Scala because they come built into the language and you can use them out of the box. But internally, they're still represented with numbers. And numbers, by the way, they all can be represented as just ones and zeros. So everything, as you may have heard, is made out of zeros and ones, but we are not going to be covering how exactly you can build numbers from just zeros and ones. So color is like a div, percentages of like different percentages of red, green, and blue, writes John in chat, and letters have corresponding numbers. So yeah, if we remember how the colors are defined, they are defined in terms of red, green, and blue components. So there is a component for red, green, and blue, and there is a certain percentage of red present, like 50%. For green, maybe 5%, for blue, maybe 0%, and this defines some color. So if you change those percentages, you can define any color whatsoever. So the thing here to notice is that we cannot represent a color using just one integer. It's not sufficient to just say one number for red, for example. We need 3 numbers. So the idea here is that the data type of color is built not out of a single other data type, but out of 3 data types. So it will be 1%, 2%, 3%. Or in the real world, it's not percentages really, it's actually integers. Or it can be also not integers but doubles, depending on the internal representation of the system. But the point is that you need 3 numbers to describe a color. And the same can be said, for example, about things like, say, Facebook post, for example. So Facebook post. Can anyone tell me a combination of which data types it can be? It's not only the Scala data types. You can name any data types that come to mind. Just tell me the combination of which since it is. What does it consist of? Yeah, comments. What else? A picture, photos. What else? There can be video. That's right. Anything else? Info. Which kind of info? Probably you mean the text that is written in the post. One of the most important parts of any post is the person who posted that, because there is no post if nobody posts it. So yeah, you see how a Facebook post is a combination of picture, video. By the way, picture can either be there or not be there. Video can also be empty. Comments. What else? Person, etc., etc. So you see how all of the data types, they can be built out of other data types. And we also need to remember, like, the importance of the data modeling is that the way you model the data defines how you're going to work with it later, defines the logic you're going to be able to run on that data. So it is important to start to define your data correctly. So we are going to be looking at how to solve the problem of modeling this flights database in Scala. So flights database, it is essentially many flights. So if you look at this database, it is just flight 1, flight 2, etc. So it is just many flights in one collection that we can do certain things on. Therefore, we need to know how to model two things, which is, first of all, how to explain Scala what is a flight. And second of all, we need to explain to Scala what is a collection of something. So the collection is going to be responsible about storing all the flights, and the flights are going to be responsible on storing the information about the individual flight. So the idea of a collection is pretty important, and it is present in most of the programming languages out there. And it is present all the time when we are dealing with many of the same kind, many things of the same kind. So, for instance, what can be a collection? A collection can be, well, a database of flights. What else can be a collection? It can be, if we go to that same sky scanner, for example, look up the flights, you see that there are many things of the same kind. So there is first flight that I'm showing you with my mouse here, highlighting here. And we see that the second flight is essentially the same kind of data as the first flight. Then we have many other flights that are essentially of the same kind. If we are talking about, for example, Facebook comments, it is also the same thing, because there are many things of the same kind. There can be many comments. and there are the examples of collections are ubiquitous. Now, can anyone name me other examples of collections in software and in real life that you may think about? So Olga says list. List is an abstract collection. So it's like a general case of a collection. But what I was asking about is like the concrete examples of where we encounter them in practice. So John says music albums. So that's right. You can imagine going to a store and there will be a lot of music albums on the shelves. And it is very likely that the store internally, they have a tracking system that have all their inventory, all their goods stored inside the computer. And it is more than likely that all of those music albums, they're actually stored as a collection inside of the computer so that the store managers can at any time, at any point of time, know what they have. So Stanislav writes emojis. That's also correct. We have a lot of things of the same kind. So that can also be considered a collection. A library of many things, John says. So I assume, well, a library of books it can be, a library of other things, maybe. So yeah, in library it is the same case as in music albums, as in with music albums. So in library you also come to the library and you have a computer which shows you all of the books that are present in this library. So you can use that to find any book you like. So, okay, that's pretty accurate. You understand the idea of collections. So now we are going to see how exactly we are going to be representing the individual flights first, and then how exactly to unify them in a collection in Scala. We have already seen how color is assembled out of 3 data types. And let's see what a flight can be assembled of. Well, a flight, it is a combination of the city you depart from, departure, destination, and price. There are a couple of other things that go into flights usually, but we are not going to be complicating things with them. So let us go into Scala and see how we can represent an individual flight with Scala. So for instance, a flight from Helsinki to Barcelona. Well, first we can store it in a variable. Sorry about this thing that got opened. Flight. So flight will be, well, to unify several things into one, several data types into one, we can use a so-called tuple in Scala. And a tuple is, simply put, several pieces of data that are written inside parentheses separated by commas. So the first element will be departure city, which is Helsinki. Then will be the arrival city, which will be Rome, and the price will be 150, for example. And then you can print this. And you see how Scala represents it internally, how it prints it. You can access the elements of this tuple using the ._ syntax. So ._1, for example, gives you Helsinki, 2 gives you Rome, 3 gives you the price. You can also access it using the parenthesis syntax that we will see more of later. So parenthesis, and inside the parenthesis you write the index. So 0 will be Helsinki, 1 will be Rome, and 2 will be 150. So this dot syntax, it's something we are going to be seeing a lot of in Scala, and the right way to read it is owned by. So flight dot underscore 1 is it means underscore 1 owned by flight. So you can define more of those flights. So this will be flight 1, flight 2, Rome to, say, Barcelona, 200. And then the first element of the first flight will be Helsinki, first element of the second flight will be Rome, and so on. John asks in chat, when you write val flight and a tuple and print line flight, why the parentheses were also printed? So the question is, when we print the flight, why do we have the parentheses here? And the answer is, well, because that's how Scala prints tuples. It's a standard representation of tuples in Scala. So a tuple is a single piece of data for Scala that consists of other pieces of data. And every piece of data in Scala can be printed. And Scala has a default way of printing every piece of data, every data type. And so this is just the default way of printing as a tuple data type in Scala. Now, that's how we represent individual flights in Scala. Now the question is, how exactly do we represent a collection of those flights? And the collection is represented using a data type called list. And this part can be a little bit confusing because the question arises, the question will arise when exactly to use the tuples and when exactly to use lists. So let us first write the things the right way, so the way we are supposed to write the collection of flights, and then we see how exactly to determine when exactly to use which data type. So flights database, flights database is a list, and then in this list you can write all of the elements that go into this collection separated by commas. Flight 1, flight 2, so you can then print this. Flights database. So again, it goes back to the thing that I was saying, that Scala has a standard way of printing all of the data types. So list is also a data type, but it is a collection data type. So a standard way for Scala to print the list is to print, well, list, and between parentheses to print all of the elements that go into this list. So for instance, if the flights database is not a list of tuples, but a list of numbers like 2, 3, 4, 10, and we run this program, then we see that the list gets printed. Well, also we have list, but inside parentheses we have numbers and not flights. So let's put the flights here back. So we can also write the flights directly, not using variables, but using variables may be a little bit more convenient here. Now the most interesting question here is okay, you can write several pieces of data, unify them into one piece of data using tuples, but also you can do that using a list. Now, when exactly would you use which option? Does anyone have any idea? Can you please write them in chat? So when do we use when do we use lists and when do we use tuples? What is the difference? Like, why can we not just define the flights database using the tuple syntax like this? I mean, we can print that and it will also work. If we leave the list, we can access individual members of the list using the bracket syntax. So list database of 0 will be the first element of this database, so the first flight. And if you define it using a tuple syntax, it will also be accessible using this bracket syntax. So what is the difference? Can anyone tell me in chat what is the difference? John says a list contains data composed of tuples. Well, a list can contain not only tuples, but also, like, you can put anything you like inside. You can put strings like foo, bar, and it will also be a valid list. And you can put numbers, as we have seen before, and it will also be a perfectly valid list. Stanislav says maybe we use tuples when we don't want its content to be changed. Well, the problem is that lists are also immutable structures, and they also cannot be changed. So in case of tuples, if you want to change the tuple, what you do is you copy the tuple with different information. So if you want, for example, to change the price of the first flight, maybe it got up, so 200, for example, instead of 150, what you do is you copy the entire tuple and set the new price inside. And if you want to do the change to a list, well, you also do the same thing to a list. You will copy the entire list while adding the new flight inside the list. And this might seem inefficient, but in fact it is not inefficient, because the copy operation, it preserves, it doesn't copy each individual flight. It just copies the location and references to those flights in memory. It doesn't copy the internals of the flight. Stanislav says maybe tuple normally shall represent one unit while list group of units. John says list is used when you would like to perform many different logic to its elements, while tuples are only data themselves. And Olga says tuple contains the units. So I'm not sure what Olga means by units. Tuple contains the units. I mean, tuple can also contain other tuples. So for instance, we can do tuple foo, for example, and it will be, I mean, we have already seen how it contains other tuples, because we can represent the flights database as a tuple of two flights. So we have a tuple of tuples. And if you print it, we'll have a tuple of tuples. So John and Stanislav, they are both correct. So the lists are used when we want to represent a group of uniform things. And John says list is used when you would like to perform many different logic to its elements. So that's also correct. Let's see what exactly that means. So to see that, to get into the topic of when to use lists and when to use tuples, let me ask you again a question that I was asking you before, which is essentially the same question, but in a simpler scenario. So in Scala, what is the difference between 2 and 2? Written with quotes and without quotes. So what is the difference? When you should use what? In essence, it is the same question as I was asking just now about tuples and lists. Olga says data types. So yes, there are different data types. Well, list and tuple are also essentially different data types. But the question is, when do we use what? When do we use which data type? Like, what defines the usage of what data type? Do you, for example, use, yes, Stanislav writes, when we want to represent text, we use to as in quotes. So that's another way of saying it is of type string. But do we use, for example, the version with quotes when we are having a mathematical application such as a calculator? Would we use to in quotes in such an application? So yes, we do not use it in such kind of application. You are right in chat. And why do we not use it in such an application? Why can we not use to in quotes in the calculator scenario? It is not correct data type for what? For addition. So that's what I wanted to hear. So the thing is that to and to in quotes and without quotes, they have different logics that can be performed on it. So to without quotes, it is an integer. And on integer, you have all of the mathematics logic, for example, defined. And to in quotes, it is a string. And on a string, we have logic that is specific to text. So we can say get nth character, like when you have a text and you want to get nth character, add two texts together, and so on and so forth. So logic that is specific to text. And notice how this plus and this plus, they look the same, but they will be completely different for these two data types. Because can anyone remind me what will be 2 plus 2 if you put them in quotes? Right, so that will be 2, 2 without the space in between. So it's important to know that this plus over here, it does not put the space in between the strings that you add like that. But the idea is that the data types, they define the logic that can be performed on those data types. And so list versus tuple, they are differentiated exactly using the same logic. So they have different kind of logic that can be performed on those things. So when we write, for instance, list flight 1, flight 2, and F1, F2, flight 1, flight 2. So it is both a valid way of writing two flights together, like a collection of flights, but it will be exactly the difference, exactly the same difference as between two in quotes and two without quotes. Two different data types and two entirely different sets of logics that are possible of being performed over these data types. So this will become more apparent when we move to the next chapter about the logic that is needed to actually implement the flight search engine. But to give you some idea, give you some intuition of what kind of logics are defined on what. Well, for a tuple, we do not have much logic defined. It is just used for combining the data types together. So it is just a way to model the domain. But for a list, so for the tuple, it is like virtually no logic, virtually, but because there is still some standard logic that is defined in it, like for instance, you can copy tuples, for example, and so on, but it's irrelevant for our cases. But for list, for example, we have a lot of logic defined for a list. So all of the logic that is defined for a Scala collection, it is characterized by that properties that it does the same operation for all of the elements. So you define an operation once, you give it to the list, and it will do the same operation to every single element of this list. What is an operation? What is an example of an operation? It can be, for example, printing stuff to the screen. So you might tell the list how to print a single flight, and then based on this information, list will print you all of the flights because it knows how to print one flight. What else you can do is you can copy the entire list while transforming each of the elements of this list. So, for instance, if you have a function g, and we will cover functions later, but they're like methods. Basically, it is a formula that takes a flight and produces another flight as a result. So maybe it is a formula that adds some price to every flight, to every flight's price. So this can be useful, for example, if you have an increase or a decrease of price for all the flights in your collection. You might tell how to increase the price for one flight, and then this list will be able to do that for every single flight in this collection. So you tell how to increase the price by 20% for one flight, and list will increase the price by 20% for all the flights. Another example of logic on lists is filtering. So filtering is when you take a big list and then you have some criteria by which you leave or drop the items from that list, and then you're going to produce another list that is that matches that criteria. So you tell, for example, that you say that you only want flights that are cheaper than $20 or $200. So you can say how to check a flight for being cheaper than $200, which is f_3, because 3 is the price of the flight, and you say that it is less than 300 or 200, I said. So you tell Scala how to test one flight to be less than 200, and then it will be able to give you a list that contains only the flights that are less than $200 of price. Nothing of which is possible for the tuples. So whenever you're having some kind of database situation, you are going to be using a list and not a tuple. So now to check, to harden your understanding, maybe it is a good idea to take a look at one of the homeworks that we were doing for the chapters that we are currently analyzing. And the homework sounded like this one. So imagine that you're working on an application where you track all of your expenses, and you represent an expense that consists of a name and a cost. For instance, a $5 meal at McDonald's. And how are you going to represent that in Scala? So it's also the same task as with flights. So you have a collection of something and a collection of expenses. So now my question to you is, how would you model an expense in Scala? And an expense is defined as it is defined in task. It is price of the meal and a price of the expense and the description of it. So how would you model the $5 meal at McDonald's for such a budgeting application? Any ideas, anyone? So John writes her example. Yeah, okay. But the idea is clear. I think what you meant is you want a tuple, and in that tuple you have the name of the expense as a string and the price of the expense as an integer. So what you wrote is drinks and then Coke 5. Now the question is, how do you model the database of your expenses? And my question to you would be, if you have like several expenses, well, are you going to use a list or a tuple to model a database of such expenses? Any other thoughts? Any other options? So yes, the idea that we are going to be using the list. So now you understand a little bit the idea of the distinction of when to use lists, when to use tuples. And just to harden the understanding even better, I can give you some guidelines about how to select in various situations what to use. So some questions to ask yourself would be, first, does my collection, does my data type, does it have a fixed number of elements? Now, if if all the entities of the data types that we are trying to define, they contain a fixed number of elements, is that going to be a tuple or a list? What do you think? So yes, you're absolutely right. It will be a tuple, and otherwise it will be a list if it has a different number of elements. If the number of elements can vary. Another question that you can ask yourself is, does this thing, does it consist of pieces of data of different data type? So what in this case, will it be a tuple or will it be a list? So the answer here is that it will be a tuple, and the reason it will be a tuple is because for a list, it is imperative to have the elements of the same type inside the list. Why? Because it goes back to the logic that is defined on this list. And the logic that is defined on this list that we have discussed previously what it essentially does is you explain to it what to do with one of the elements, and then it can do the same thing with all of the elements. So if you have, for instance, animals and plants inside the list, well, you will need to define a set of logic that is the same for those two things, for both animals and plants. So there is animal, there is plant, and then there is, well, the thing common about them is, for example, that they're like living things, for instance. So in that case, you will not have a list of animals and plants, you will have a list of living things. And you will be able to only do the logic over this list that you can do. Well, you will only be able to do the logic over each element of this list that you can do on a living thing. So it can be an animal, but you can no longer say, like, filter it as an animal. Like, for instance, say a situation that you want to, you have this list and you have a database of these animals and plants, and you have the tasks that you need to filter all of the plants with the, like, say, length of the, or not the length of the root, but for instance, color of the leaf, or even simpler, you want to filter all the plants that have their leaves during winter. And sorry if I do not know how to name this kind of plants correctly, but the idea is that some plants, they have their leaves during winter, some plants they don't. So then you will have to ask yourself, can I ask the same question about an animal? Is this question valid for animals? And the answer is no, it is not valid, because animals, they do not have leaves. And so if you have a database of which contain both animals and plants, you will no longer be able to filter this database by this criteria, winter with leaves. You will only be able to filter it by the criteria that is similar to all the living things, which is, for example, years alive or time alive, just to make it more general. So that's what happens if you put several things of the same kind into a collection, into a list. And if you put things that do not have any logic at all in common, then you will not be able to do anything with this collection. So, for instance, if you do something like list of 2 and 3, so one is a text and another is a number, yeah, sure, you can define such a list. Scala will allow you to do that. But the thing that will happen under the hood is that Scala will generalize the type of the elements of this of this list to any, and any is like the most general data types that you have in Scala. So you say that you have a list of anything at all, and on any there is not much logic defined. You cannot do much on those things. So yeah, sure, you can define such a list, but it will not be a lot of use. So just to conclude, if you have the case where you have different types in your thing, in your collection, in your data types that you're trying to define, then you need to consider using the tuple, especially if there is a fixed number of elements, because sometimes there is still the case where you have different types and there is a way to generalize the logic between those two types. Like, for instance, in the living thing example, so animals and plants, yeah, you can conceive of doing that. But if you cannot generalize the logic, then you should use a tuple. And another thing that you need to look at is so treated equally. So it means, is the meaning of each element of the combined data types that we are defining, is it the same? Like, for instance, the meaning of the first element, is it the same as the meaning of the third element? So if they're all treated equally, will it be a list or a tuple? So yes, the answer is that it will be a list. So inside a tuple, usually we have more differentiations. So first element, it's like in our flights example, first element, it always corresponds to the departure city, the second element to the destination city, and so on, and the third element to price. So that's the way it works. That's a criteria that you need to use that you can use to differentiate where you use tuple, where you use list. But the main thing to remember is that this situation where we have two data types that look very similarly, but are still two different data types. It is encountered pretty frequently in programming. In fact, it is encountered on every step, like even not in programming languages, even when you're considering which service to use, for example, to host your website. You have two different services and you don't know which one is better, which one is suitable for what. And the answer is in the things that you can do with these services, with these data types. So two different data types that do the same thing. You ask yourself, well, what is the logic that I can do on both data types? You try to see them in the real world and see which one is better in which situations. So this is what I wanted to cover during this seminar with you guys. I figured we will cover the case classes together with the logic on those data types in the next seminar, during the next seminar. So stay tuned until that time. And are there any questions about what we have covered today? Is everything clear? Amazing. Then happy to hear that it was clear for you guys. And in that case, have a great week ahead. And as always, I'll upload this recording a little bit later. And see you next week during the next seminar. Take care.